We are going to see the dot product. The dot product is the multiplication of two vectors that become a scalar that is a non-vector. So vector A dot vector B produces a scalar number. Say scalar number. That is a number and is not a vector. This is first the definition. This is A dot B is equal to the magnitude of A times the magnitude of B times the cosine between the cosine of the angle between A and B. This is, if this is the vector A and this is the vector B, is the magnitude of A times the magnitude of B times the cosine between these two vectors. Let's calculate first A dot A. So is A dotted with itself, so with A, so would be the magnitude of A times the magnitude of A times cosine of 0 degrees. Cosine of 0 degrees is 1, and we have the magnitude of vector A squared. So A dotted A is the square magnitude of A. Next, let's see if we recall the cosine law. We have that the magnitude of A plus B is equal to the magnitude of A plus the magnitude of B minus 2 times the magnitude of A times B cosine of the angle. So this is the dot product. So we could say A plus B is equal to magnitude of A plus magnitude of B minus 2A dot B. If we want to know A dot B, so we have, I send this here and this here, so I have 2A dot B is equal to the magnitude of A plus the magnitude of B minus the magnitude of A plus B, divide both sides by 2, and we also have that A dot product A dot B is this. Other thing is, let's say A has the components AI plus A1 plus A2J plus A3K, and B has the components B1I plus B2J plus B3K. If we do A dot B, we will do, we will do the magnitude of A times the magnitude of B times the cosine, but other way is just to multiply each term by each term. It's just a normal multiplication of this, let's say this sum times this sum. This is going to be, at the end, will be just A1, B1. We are going to see why in a minute. A1, B1 plus A2, B2 plus A3, B3. And this will be just a number. For that, A dot B is a scalar number. Dotted the vectors is just a scalar number. This is because if we do A1 I1 times B1 A1 plus A1 AI times B2 J2, that is, we are going to multiply this plus this plus this plus this, and then this plus this plus this, and then this plus this plus this. We're going to have 9 terms, not just 3. But the angle between the component A1 I, B2 J, this is the unit vector I, and this is the unit vector j. So they are orthogonal. So when we have orthogonal vectors, that is, the cosine of the angle, cosine of 90 degrees, is 0. So it would be 1 times 1, because they are unit vectors. So it would be length 1 times length 1 times 0 would be 0. And then multiplied by whatever these constants are, a1 and b2, whatever b times 0 would be just 0. So for that, this and this is 0 and we do not count it. Next, also, j, let's say a2j dot b I2. Also, when we dot this with this, we have j and I. That will be to 90 degrees angles, so for that they die. So will be each term that has I with j or I with k, here j with I, k with I, and j with k, j with k, j with k will die because all those unit vectors are at 90 degrees. So the cosine will be 0 multiplied by the unit length, or by this unit length would be 0, and by whatever constant b, this a2, b, a3, b2, whatever would be 0, because we're multiplying by the cosine of the angle between the two unit vectors. So for that, we only have a1, b1, well, a1 I dot b I plus a2j dot b2j plus a3k dot b3k. Now this a, vector a, and vector b are in the same direction, so it would be length of a times length of a, length of a, that is, well, the length, or we could say it like that both are in the I component, I direction. Let's say this is I direction, so we could say a a1 dot b1 like this is equal to, because these are just two constants, so it would be ab times I dot I, and which is I dot I, that is the length of I times the length of I of the unit vector times the cosine of the angle between I and I. This angle between one and the other is 0 degrees. So we have just the magnitude of I times the magnitude of I, that is just 1, and then, so a1 I1 dot b1 a1 I dot b1 is just 1 times ab, for that is a1 b1, and the same applies for j and k. The important issue here is that yes, we have three terms, but the I, j, and k disappear because we are dotting each term with the other term. We already saw that a, j, or j, k are going to die, but I and I, j and j, k dot k is just the magnitude of k times magnitude of unit vector k times the constant. We have b3 and a3, but we have only these terms, and we do not have to put I or j or k because we are dotting them, and when we dot we have a scalar product, and the I dot I was just 1 times cosine of 0, that was just 1, and we just multiply times these constants. So for that, a dot b is just a scalar product. For that, a dot b is called the scalar product. The other thing that is useful is if we have a and b, so here is a and here is b, this is theta, the projection of a on b, we have two things. One is the scalar component of a in the direction of b, and the other is the, let's say, the vectorial projection of a onto b. I think that this is simpler. Let's first see the scalar component of A in the direction of B. That is, how do we calculate this, let's say, the component of B of A, the component in B of A? Well, this is just the magnitude of A. Well, we'll put it here. It's just the magnitude of A times the cosine of theta. A times the cosine of theta. But what's this? This is the same as we have A dot B is equal to magnitude of A times magnitude of B cosine of theta. Here I just have A cosine of theta. So this is A cosine of theta is equal to A dot B divided by the magnitude of B. And this would be a scalar component because A dot B is a scalar number. The magnitude is also a number, is a scalar number. So a scalar divided by a scalar is going to be a scalar number, and for that this is a scalar number. It's just a scalar component, it has no magnitude, no sense. Also, you could say that the magnitude of A is a scalar number. It's just the magnitude. Cosine of theta is just also a number. So within a scalar time, a scalar would be scalar. So here we do not have any vectorial in any direction, just the scalar component of A onto B. In the next video, we are going to do some exercises about the dot product. The other is now the vectorial projection of A onto B. This is, we have A dot B is equal to A B magnitude of A and magnitude of B cosine of theta. The vectorial projection would be the vector A in the direction of B. That would be the scalar component, that is A dot B divided by the magnitude of B in the direction of B. But what's the direction of B? This is magnitude of B. We have the magnitude of B. We have the vector B. This is the vector B. But it's a, let's say, 2i plus 3j plus 4k. We want the direction of B. That would be the unit vector, a unit vector in the direction of B. So B divided by the magnitude of B gives us the direction of B, or a unit vector in the direction of B. So we will have 2i divided by magnitude of B plus bj divided by the magnitude of B plus b3 or 4 divided by the magnitude of B. We will do all this in the next video, these exercises, but here is first the concept, and yes, in the exercise will be more clear, but first the concept. Next, now that we have the direction of B, we want to know the vectorial projection. Here, vectorial projection of A onto B. So we have the scalar component of A and the direction of B. We have the scalar component of A in the direction of B and the direction of B. So it would be the scalar component of A onto B times the direction of B. So it would be A dot B divided by B magnitude times B, I forgot the vectorials, divided by the magnitude of B. This is equal to, I could say, A dot B divided by, we already saw that the magnitude, the square magnitude of B, we already saw that was B dot B. So I could put here B dot B times B. This is other way, and you can do it as well. For me, it's easier to, if I want to know the vectorial projection of A onto B. For me, it's easier to first calculate the scalar component of A onto B, and then I just multiply that times the direction of B. That is, I first calculate this, then this, and I multiply them. Instead of do this, I calculate A dot B divided by B dot B times B, and that actually is exactly the same multiplication. I have to do this first. I do this first and then this, but it's exactly the same. Here you have A dot B. You will do it as, yes, obviously you need to do this divided by this, so you do it this, A dot B. Then you do B dot B, that would be the magnitude that I usually would take or calculate the magnitude in order to do B divided by the magnitude, but here you calculate the magnitude, and at the end you multiply by B. So it's the same, A dot B divided by B times B divided by the magnitude of B is the same as first A dot B, then divide in B dot B, and then multiply times B.